Okay, we want to look in detail at this help menu here. We just briefly roughed over it very quickly. Everything that you will need is in, more than likely, in this long list here. And if you click on the main river help, it will tell you what the last version was, and it will help you navigate through everything you need to. It pops up as an HTML, so it's not, it does look different from the original file. That's not important. What is important is you read all this stuff here and get to grips with it, find out what you've got to do. You will be seeing the workflow in a minute, but here's a basic layout. Set up a new project. Down the middle bottom, river data import, data processing, plot river layout. This is basically the rough format. You get your data in, you start processing the data, and you can then go to either live CAD editing there or plot river layout and get your changes in. You'll need there your DXF river center line that is digitized from the bottom up, always on the OS master map style maps. And by doing that, you will then interact with the DAT file, and the header files will then have various bits added to them, notably which is the chainage, the distance up the river to the intersection of the river center line and the line of the section between the left and right bank points. There's a lot of stuff in live CAD there, general cross-section working codes, and this is where you're going to start to get to grips with all this stuff here. And two-letter codes only. Generally, you can call them straight or curved and have a Okay, so we're looking at these two-letter codes here. Here we are. We've got HB 105 SOGs. We're on the first river, 5th section, and we're working across a field with a hard bed, and we're using soil, SO, and grass, GS, to give the 4-letter suffix, which creates for each point exactly what the surface type is, and also the vegetation type. This is used critically in the EACSD format, but also virtually all the modeling export files now insert the list that we saw earlier, or we can see here rather, those two-letter codes. It starts with bed material types, then goes to vegetation types, and so that all there is used in terms of creating the Manning's roughness values for individual points in the exported modeling files. So that's really quite important. There's lots of things. You can see there's an old plan showing how it was best to survey 4 cross sections. So that's your main overall general help. This is the site survey overview, which we've included here, and I'm hoping I can zoom in. There we are. Now, this is a watercourse. I think that's David James on the left there, a younger David James, and these are the points which he has taken. You can see the character of the points that we're taking. They're fairly close interval down the banks and in the river, but we still like them probably less than 5-meter intervals off the bank and going leftwards. And you can see the codes at the top, HB 105 SOGs there, offence, FE offence 105 SOGs, and you note the size and the type. Now that is goes in the comments area. We can look at those later on. So David has actually surveyed across this whole watercourse. It was one of the bigger ones in the flatland south of Rhyl and Prestatyn in North Wales. So, and here's your dimension guides here for everything. It looks complex. Once you get into it, it becomes second nature. That's all the information there. Here's your lists for the soil and vegetation. Now this is a bit more interesting because it involves a structure. We like to try and get these vertical sidewalls and straight line soffits of any concrete culverts. Might be a masonry arch, in which case you're going to take the bed profile across. We haven't shown it properly here. The bed profile that you saw here would be taken against, or as close as you can, to the face of the bridge. In terms of the structure information, note it very carefully. We need the road deck. There's the DK on that one there. We want the handrail, anything that looks like a handrail or is a device that would actually stop water flowing through it. And we've then got the BE code. You can just about see that. So there's a BE code. It starts at the bottom and it goes to the lower part of the chamfer on this precast concrete culvert. Then you get this one here, which is the top end of the soffit, the right top end of the soffit, down onto the chamfer and down onto the bed. And the same, so that's copied there. The parapet, this one here, goes across from that point there to over to there. So I'll get rid of that somehow. And so we're picking up the parapet. So you start with the deck, the handrail, then you've got the parapet, then you've got the BE code for the opening. Might be a CT code for a culvert, and you can see down the bottom if you've got any culverts are coded, e.g. CT 105cc, with a size note, either normal for invert or negative as a minus value. If you can only take the soffit of a culvert, a circular culvert soffit that is underwater and in silt, then you can put a negative value for the diameter and it will draw it correctly below the point that you've taken. Any outfalls near the section use OF. Now that's critical. The software looks for BE codes and CT codes along with the DK and the parapet and the handrail to create a section which is it knows it is a structure. That's why you've got the 10 header variables. We only use CT if you want the cross section of the structure to be in line on the long profile. Any outfall that you see along where you've got, or any outfall coming in, might be road drainage, a small pipe coming into the side wing wall, any outfall here or any that you pick up along the watercourse, just call it OF. In this case, it's going to be 105cc. There is a slightly different setup for dealing with outfalls in the open, and it relates to the river that they're on. So you might have OF 100. Which means it's the first river and it's an outfall on that. The software deals with that very specifically separately and creates its own file of outfalls, bank levels and wall levels that are placed along the watercourse. They don't get used within the structure area. Okay, let's just go past that one and then we can go on to this is an interesting one which we introduced. If you have an iPhone 13 or more newer than that, you can use the LiDAR scanning, which is the black circle just there, within 5 meters, and it will create a draped photograph looking like this here. There's a canal bridge. It's really quite interesting. It can be fairly quick to do it by working along. You soon get used to it. And what happens is that you can't quite see it in this view there. So can I zoom in? No, we can't. It triangulates points of the surface of whatever it's looking at, and then it overlays the information on it. Let's just see if we can pull this one in. Oh, there we go. Here we are. This is one I created earlier. It's a canal bridge, and let's go back to the beginning and start again. Now that you can create a video, so you can't stop it, but at least you can see what it is. If I then go and control click on this one, it should come in. Here we go. And that is simply another a bigger culvert underneath a canal. If I can stop it there, hang on. I can pause it, 2 ticks. You look, so you're looking, actually, I walked up inside, but because I didn't have waders on, I couldn't get into the watercourse and get the arch of the tunnel too easily there. But it got some of it, and you can look, I could get into it fairly quickly downstream. And in the next one, I'm going to give you the 3D view, but it shows within about 5 or 10 minutes, I've quickly scanned the whole of that structure, got up inside, and you'll see now in here that you can go, and I'm going to go into this polycam poly object. If I click on that, it'll take a few seconds to come in. It uses the 3D viewer in this normal Windows software, and here it is. Look at that. I'm really thrilled with this sort of thing. You go inside, you can move it around, you can see the roughness of the water. This is a canal, clearly it's not going to be a flowing river, but it was nice and easy to get into. And then if you go up on the top, look at that, you've got the track, you've got the wall, even the stock logs down on the left there. So this can be done, and if you wanted to do it, all you're going to do when you come to name your photographs is simply call them CS1-01, and you could call it video or 3D video, whatever you want, because it will then, when you come to renumber the photographs, and we'll see that later on, into a chainage suffix format, where you've got, you may be a, the chainage up, the watercourse might be 004312 decimal point, and then the cross-section number and so on. It will still work with a video like that, but it can be done, and it's very easy and simple to do it. Here's your importing the river processing data. I was talking about the outfalls, banks and walls. There are two main sections, types of data. You've got your section data and your alongside the river outfalls, banks, walls data importing. It's all in there, and it shows you how it works. There's your the code for the outfalls. The watercourse, the risk code system is reliant on the watercourse numbering 1 to 9. And so all the information is in there. Let's go to the next one, recent residual readme. There's something in there. If you're really desperate about there's difficulties or admin or whatever, you can look at that one. Recent revisions. This goes back, as you can see, a long time. We only started putting revision numbers in 2019, and I think it's about 40 iterations up to version 2.05, saying what were the last things that were done, and so you can always check back if you ever wanted to. And this is one of the most important ones, the exporting of georeferenced photographs. Another big help file. You've got to read it through, get your brain around it, and we can use expert GPS. We can import the photographs in there as long as they are referenced correctly to latitude and longitude from the camera. I'll tell you later about how you can, if you haven't got that on your camera or you've forgotten to implement it, you can insert into the EXIF, the EXIF file, a portion of the JPG. You can re-import, if you like, the center point of the cross-section OS National Grid coordinates converted to latitude and longitude, and then so you'll see then all your section photographs overlapping along. Then that can be exported as CSV files and so on. Here we are now down into the dimensions format. This all built up over a period of years. Here's, if you want to put a fence, then you're going to have in the DAT file the FEX of the code for the fence. It's a single point. 19.46 is the offset on the section. 10.06 is the level value, and in this block here is the comment area before the coordinates easting and northing at the end, and that indicates that is a 1200 high, in this case a post and wire fence, and the ground point there is CC and NO, concrete, and no, there's no vegetation, it's purely a bit of concrete. We're looking at the coding is for the next point. In other words, if you've got your fence at the side of a concrete road or whatever, then the next point is concrete. And so there's all that there. The bridge length code, that can be put in later on if you haven't done it on site. The pipe codes, the water level code there, you can put in time and date. The system will recognize, as long as it's in that format, it will recognize it and put it in the on the cross sections. Here we are, there's the bridge width date, the BE code, and here we are. This is really, really helpful. If you've got a face measurement for this particular BES code here, you can have this all on. You're only going to have one string of BES, but you could start. The first one says, I've got a measurement with your disto along the face of the bridge of 10,320 millimeters F. If it's a minimum, if it's the structure twists or skews inside, and you've managed to get inside safely and done a minimum inside width, this also is critical. You can put in then 9900 M. There's your minimum inside width measurement, and this one here is your structure opening, and that will all get included then in the live CAD. Here's your CTX, your culvert diameter, that's all in there. Circular outfalls, you can even put in outfalls which are rectangular. And so long as you put in, say, 500 x 900, you will get the correct height and width of that box culvert. The trash rack, that again is critical. They always need this stuff. You can put TRS code, and you as I say, we in the past we use an ST code for steelwork. You don't need to worry about that at the moment. TRS is there this year, and you can put in there 16x11, which is firstly the number of steel bars, and secondly the width of the bar in millimeters. That also is critical. That's all the outfalls and banks on walls there. So again, there's huge amounts here. Bank data codes help. Oh, that's our list where we've got the first two letters of the surface type, tar macadam, might be gravel for the bed and so on. And then we've got if you were going across the bed and there's free floating parts, it's FF. There's GS. Now it's normally GS, and then vegetable we've got closed hedge, HC, and the rest of it there, and that all follows through and it gets put onto the drawings. Again, very critical stuff there. And if we go down to the bottom, this is only for very special circumstances. If we've got a concrete wall flood defence, we can put CW, and the reason why there's a plus sign in there, it plots it, concrete wall flood defence, with an underbar, it splits it on two lines, concrete wall, carriage return, flood defence, and it will put it central on the CW, the concrete wall point that you want there. I'm going into too much detail, but I'm starting on it. You probably don't want to get worried about this. Infomap website, and here it is here coming in. This has been renewed recently. Lots of stuff about Infomap surveys in there, but that really gives you a good run through all these help files. As I say, there will be the videos list will be at the top, and so that's really quite a hefty chunk to have to go through. Thank you for listening.